Hey guys, welcome back, I'm Jay. In this episode, we're gonna look at Amazon DynamoDB. Amazon DynamoDB is a key value and document-based NoSQL database that delivers single-digit millisecond performance at scale. DynamoDB is the semi-structured database that allows you to easily update the data structure and schema over time. DynamoDB is the serverless database that removes the burden of installing and maintaining any servers or software. DynamoDB automatically scales capacity to maintain high performance. You can start small and scale up to support petabytes of data and tens of millions of requests per second. DynamoDB has built-in high availability and fault tolerance, as data is automatically replicated across multiple availability zones in one region. It also supports cross-region backups and global tables with multi-region replicas. DynamoDB is suited for a variety of applications and businesses, such as advertising, gaming, banking, retail, media, software, and internet applications. DynamoDB stores data in tables. Each table is a collection of items, and each item is a collection of attributes. For example, you can have an employees table to store information about employees, including contact information, employment histories, and employee IDs. You can also have a teams table to store information about team members, projects, and team leaders. Here is an example of a DynamoDB table. A table may look like a spreadsheet on the left, if you access it from the AWS console or using a DynamoDB client. If you query the table using API or SDKs, it returns a JSON document that looks like the figure on the right. Each table can contain 0 or more items. An item is a group of attributes that is uniquely identifiable among all of the other items. For example, in the employees table, each item represents an employee. The maximum size of an item in DynamoDB is 400 kilobytes. Each item is composed of one or more attributes. An attribute is a fundamental data element. For example, an item in the employees table contains attributes, such as employee ID, first name and last name. DynamoDB supports several data types for attributes within a table, which can be categorized as scalar types, document types, and set types. The scalar types include the number, string, binary, boolean, and null types. Each scalar type attribute can hold exactly one value. The number type can have positive, negative, or 0 value. Each number can have up to 38 digits of precision. The string type can be a Unicode string with UTF-8 binary encoding. They can be text in different languages. The minimum length of a string can be 0. The maximum length is constrained by the maximum item size of 400 kilobytes. The binary type attribute can store any binary data, such as compressed text, encrypted data, or images. DynamoDB stores binary data as an unsigned byte array. When you put the binary data into DynamoDB, you must encode binary values in the base 64 encoded format before sending them. Once DynamoDB receives the encoded values, it decodes the data into an unsigned byte array and stores it in the table. The minimum length of a binary can be 0. The maximum length is constrained by the maximum item size of 400 kilobytes. A Boolean type attribute can be either true or false. Null type represents an attribute with an unknown or an undefined state. The only data types allowed for primary key attributes are string, number, and binary types. A document type can represent a complex structure with nested attributes, such as a JSON document. The document types are lists and maps. These data types can be nested within each other, to represent complex data structures up to 32 levels deep. A list type attribute can store an ordered collection of values. It's similar to a JSON array. Lists are enclosed in square brackets. Elements in a list can have different data types. There is no restriction on the data types that can be stored in a list. A map type attribute can store an unordered collection of name-value pairs. It's similar to a JSON object. Maps are enclosed in curly braces. Elements in a map can have different data types. There is no restriction on the data types that can be stored in a map. There is no limit on the number of values in a list or a map. Empty lists and maps are allowed in DynamoDB. Empty strings and binary values are allowed within lists and maps. The maximum size of a list or map is constrained by the maximum item size of 400 kilobytes. A set type can represent multiple scalar values with the same type. DynamoDB supports string, number, and binary sets. All elements within a set must be of the same type. For example, a number set can only contain numbers. A string set can only contain string values. Each value within a set must be unique. The order of the values within a set is not preserved. There is no limit on the number of values in a set. Empty set is not allowed in DynamoDB. However, you can have empty strings and binary values in a set. The maximum size of a set is constrained by the maximum item size of 400 kilobytes. A DynamoDB table spans multiple availability zones. When you write data to a DynamoDB table, DynamoDB automatically spreads the data and traffic across multiple AZs. Data is usually propagated across all AZs within a second. DynamoDB supports two consistency models. They're eventually consistent reads and strongly consistent reads. By default, all read requests are eventually consistent. When you request an eventually consistent read, to access data immediately after a write request, the response may return some stale data. If you repeat your read request after a short time, the response should return the latest data. In general, eventually consistent reads have better performance than strongly consistent reads. When you request a strongly consistent read immediately after a write request, it forces DynamoDB to return the latest data. However, strongly consistent reads come with some disadvantages. Strongly consistent reads might not be available if there is a network delay. In this case, DynamoDB might return a server error. Strongly consistent reads might have higher latency than eventually consistent reads, as DynamoDB needs to propagate across multiple availability zones. Strongly consistent reads are not supported on global secondary indexes. You need to use eventually consistent reads when you query data with global secondary indexes. Strongly consistent reads use more throughput capacity than eventually consistent reads. As a result, you need to pay more when you retrieve the same data using strongly consistent reads, comparing to eventually consistent reads. DynamoDB distributes data in partitions. A partition is an allocation of storage for a table, backed by SSDs and automatically replicated across multiple availability zones. A table can have multiple partitions. DynamoDB uses an internal hash function to evenly distribute data across multiple partitions. When you create a table or an index, you need to specify the partition key, and optionally specify a sort key, to compose a primary key. The partition key of an item is also known as hash attribute. DynamoDB uses the value of the partition key as input to a hash function, and uses the output of the hash function to determine the partition, in which an item will be stored. The minimum length of the partition key is 1 byte, and the maximum length is 2048 bytes. The sort key of an item is also known as range attribute. The sort key is optional in a table. DynamoDB uses the value of the sort key to determine how items with the same partition key will be sorted. The minimum length of a sort key is 1 byte, and the maximum length is 1024 bytes. All items with the same partition key value are stored physically close together, in the sorted order by the sort key value. DynamoDB uses the partition key, or a combination of partition key and sort key as the primary key, to uniquely identify each item. When you create a table or an index, you must specify the partition key and an optional sort key to be a primary key. You can query a table or an index using its primary key. The primary key can uniquely identify each item in the table. The only data types allowed for primary key attributes are string, number, and binary types. DynamoDB supports two types of primary keys, simple primary key and composite primary key. A simple primary key is made of one attribute, which is the partition key. For example, you can use employee ID as the primary key to uniquely identify an employee. A composite primary key is composed of two attributes, a partition key and a sort key. A composite primary key gives you additional flexibility when querying data. For example, in the employees table, you can have a department name and employee ID as the composite primary key. You can retrieve all employees from the same department by providing only the department name. You can also retrieve a subset of employees from that department by providing the department name and a range of employee IDs. A secondary index is a data structure that contains a subset of attributes from a table. DynamoDB allows you to create one or more secondary indexes, and so you can efficiently access data by retrieving only a small subset of attributes. You can issue query or scan requests against these indexes. DynamoDB supports two types of secondary indexes, global secondary index and local secondary index. Global secondary index or GSI is an index with a partition key and a sort key that can be different from the base table. Queries on the GSI can span all of the data in the base table, across all partitions. A GSI is stored in its own partition space that is different from the base table, which can scale separately from the base table. Local secondary index or LSI is an index that has the same partition key attribute as the base table, but a different sort key. The partitions of an LSI are scoped to a base table's partitions that have the same partition key values. LSI shares the same partition space with the base table. Every secondary index is associated with exactly one table. When you create an index, you define an alternate key for the index, such as a partition key and a sort key. You also define the attributes that you want to project or copy from the base table into the index. DynamoDB copies these attributes into the index, along with the primary key attributes from the base table. You can then query or scan the index, as you would query or scan the table. Every DynamoDB table can have a maximum of 5 LSIs, and an initial quota of 20 GSIs. You can request a quota increase of GSIs using AWS support. DynamoDB offers two capacity modes for the read-write throughput on your tables. They are on-demand mode and provision mode. The capacity modes control how you are charged for the read-write throughput, and how you can scale the capacity. On-demand mode is a flexible billing option capable of serving thousands of requests per second without capacity planning. With the on-demand mode, you don't need to specify how much read-write throughput you expect the application to perform. Tables can automatically adapt to your application's traffic volume. On-demand mode offers pay-per-request pricing for read-write requests, so that you only pay for what you use. On-demand mode is ideal for new tables with unknown workloads, or application with unpredictable traffic. With the provision mode, you must specify the number of reads and writes per second that you require for your application. You can also use auto-scaling to automatically adjust your table's provision capacity, in response to traffic changes. You can purchase reserved capacity in advance, and get significant cost savings compared to standard provision capacity rates. You can choose provision mode if you have an application with predictable workloads, or consistent traffic. When you choose the read-write capacity mode for the base table, both GSIs and LSIs inherit the capacity mode from the base table. DynamoDB streams capture data modification events in DynamoDB tables, such as new items being added, item updates and deletions. Data change events are recorded in the stream in near real time, in the same order as the events occurred. For example, when a new item is added to the table, the stream captures an image of the entire item, including all of its attributes. When you update an item, the stream captures an old image and a new image of the item, before and after the modification. When you delete an item, the stream also captures the deleted item, so you can run some post-deletion process. Each event captured in the stream is represented by a stream record. A stream record contains an image of the change, table name, event timestamp, and other metadata. Stream records have a lifetime of 24 hours. After 24 hours, they are automatically removed from the stream. You can use DynamoDB streams together with AWS Lambda to create a trigger that executes automatically when an event of interest appears in a stream. For example, you can create a trigger to send a welcome email whenever a new customer has been added to the DynamoDB table. DynamoDB streams also work with DynamoDB global tables. Global tables uses streams behind the scene to replicate data across multiple regions. In this episode, we've learned Amazon DynamoDB. DynamoDB is a serverless key value and document-based NoSQL database service. DynamoDB automatically scales capacity and storage up and down. DynamoDB has built-in high availability and fault tolerance. Data are stored on solid-state disks and automatically replicated across multiple availability zones in a region. DynamoDB stores data in tables. Each table is a collection of items, and each item is a collection of attributes. DynamoDB supports several data types for attributes within a table. A scalar type attribute can hold exactly one value. The scalar types include the number, string, binary, boolean, and null types. A document type can represent a complex structure with nested attributes. The document types include list and map. A set type can represent multiple scalar values with the same type. The set types include the number of string and binary sets. DynamoDB supports two types of consistency models, eventually consistent reads and strongly consistent reads. For eventually consistent reads, immediate read after write may return stale data, but eventually it returns the latest data. For strongly consistent reads, read after write immediately returns the latest data. When you create a table or an index, you must specify the partition key, and optionally specify a sort key, to be a primary key. DynamoDB uses partition key to determine where an item will be stored, and uses the sort key to determine how items with the same partition key will be sorted. The primary key uniquely identifies each item in the table. DynamoDB supports two types of primary keys. The simple primary key is made of a partition key. The composite primary key is composed of a partition key and a sort key. A secondary index is a data structure that contains a subset of attributes from a table. The secondary indexes can help you efficiently access data by retrieving only a subset of attributes. DynamoDB supports two types of secondary indexes, global secondary index and local secondary index. DynamoDB offers two capacity modes, on-demand mode and provision mode. The on-demand mode lets you scale the capacity of the DynamoDB table, without specifying the throughput. DynamoDB automatically adapts to your application's traffic volume. The provision mode lets you estimate the number of reads and writes per second that you require for your application. It also works with auto-scaling to let DynamoDB automatically scale the capacity within the provision capacity. DynamoDB Streams captures data modification events in tables, such as new items being added, item updates and deletions. It lets you record data changes and create triggers to respond to the change events. Okay, that's all for DynamoDB. Thanks for watching and see you in the next episode.
Hope you've enjoyed watching this episode. If you liked the video, please help us and hit the like button. If you want to watch more tutorials, please subscribe to the Cloudemy TV channel. Make sure to turn on the notification and stay tuned. At Cloudemy, we're passionate about cloud and AI technology. Please share your feedback and thoughts in the comments below. Feel free to let us know what topics you'd like to watch. Happy watching and happy learning.